So in 7.4 we learn a few more identities and then look at how to apply them. Most of this section will deal with what are called double angle identities, which are these identities over here on the left side of your notes. And then we have also half angle identities. So double angle identities deal with when you have the cosine, sine, or tangent of 2 times an angle. And you can see that there are 3 different identities for the cosine of 2 times an angle. Now, really, those are 3 different versions of the same identity. I mean, if you think about this first one, cosine squared A minus sine squared A, I could replace that sine squared A with 1 minus cosine squared A, distribute the negative, and have 2 cosine squared A minus 1, which is the third one. Or I could have replaced cosine squared A with 1 minus sine squared A, and I would have ended up with the second one. So they're kind of just, they're kind of all very similar. You can get one from the other. Now, why would we ever use a double angle identity? And what are the types of things we're going to do with our double angle identities? So let's look at a type of problem that you might see related to double angles. And for that, we're going to begin here with example 1. Okay, given cosine of theta is 3/5 and sine of theta is less than 0, find the following. And we're asked for sine of 2 theta, which according to the identity that I just had listed up there is equal to 2 sine theta cosine theta. Okay, so what do we need to figure this? We need sine theta and we need cosine theta. We've already got cosine theta. It's 3/5. So 2 times whatever sine of theta is times 3/5. Well, how can I get sine of theta? I can use some of the other identities that I already know. And we know that sine squared theta is equal to 1 minus cosine squared theta, which means sine squared theta is equal to 1 minus, and if we square that 3/5, we'd get 9/25, which is 16/25. And so sine of theta would be plus or minus the square root of 16/25, which would be 4/5. But we're told sine of theta is less than 0. So it's negative 4/5. So negative 4/5 goes here. And now I can figure out what sine of 2 theta is. 2 times negative 4 is negative 8, times 3 is negative 24, over 5 times 5 is 25. So moving forward, we're going to see a lot of problems that are of this nature, where we're looking for something, in this case sine of 2 theta, and we're going to have to think about what's given to us that can help us figure that out. Okay, now, let me erase some of that so we can make heads or tails out of things here. So this next problem asked me for cosine of 2 theta. Well, I had 3 different choices for that, and any of them would work here. Now, in the original problem, I was given cosine theta is equal to 3/5. So if that's all I would have been given, then maybe the best identity to use would have been this one, because it's in terms of cosine. However, now we could use either of these two as well, because now we've got sine as well. But I'm going to go ahead and use this one. So cosine of 2 theta is 2 cosine squared theta minus 1, which in our case would be 2 times, and cosine squared then would be 3/5 squared, or 9/25, minus 1, or 18/25 minus 1, or negative 7/25. Okay, let's see if we can figure out tangent of 2 theta. So to do that, we're going to need the double angle identity for tangent. That double angle identity was 2 tangent A over 1 minus tangent squared A. Okay, so that's going to be 2, and I have to go figure tangent of theta. I used A there, but really it's theta because we got theta on this problem. Over 1 minus, and we'll have to figure tangent of theta and then square it. Well, tangent is sine over cosine, and we already figured earlier in the problem that sine of theta was negative 4/5, and we were given that cosine of theta is 3/5. So tangent will be negative 4/5 over 3/5. And the 5's would cancel, and I'd get negative 4/3. So I'm going to have 2 times negative 4/3 over 1 minus tangent squared, which is now going to be 16/9. And simplify. So I have negative 8/3 over negative 7/9. Or you might hear the little drummer boy playing in the background, by the way. Negative 8/3. Huh? So times the reciprocal of negative 7/9 is negative 9/7. 3 cancels with 9 and makes 3. How about 24/7? Okay. By the way, there's another way we could have gotten that. We had sine of 2 theta figured here and cosine of 2 theta figured there, so tangent of 2 theta would have just been sine over cosine, and that would have been a little quicker actually, but it wouldn't have allowed us to practice the double angle identity for tangent. Okay, now what else we got in this section? Let's take a look here. Okay, so you're going to have some problems like that. You might see some problems like this as well, where you got some identities to verify, just like we did in section 2. Now here's the thing. Here's my suggestion. If you get a double angle identity, always replace it with what it's equal to. So you can choose to start on either side here. I think I'm going to start on the left. I'm going to replace cotangent with cosine over sine. And I know that sine of 2x is equal to 2 sine x cosine x. Now what happens? The sine x's cancel, and we're left with 2 cosine squared x on the left. Okay, now let's see if we can get somewhere on the right then. I've got 1 plus cosine of 2x. Again, we have 3 different choices for cosine of 2x, but I'm going to choose the one that had cosine squared x in it because I'm more likely to get it to match with what I've got on the left end. And if you remember, cosine of 2x was equal to 2 cosine squared x minus 1. So I'd have 1 plus 2 cosine squared x minus 1 just by replacing the cosine of 2x. The 1's cancel, and I end up with 2 cosine squared x equal to 2 cosine squared x, and we verified the identity. So really, that's not anything different than what you did in Chapter 7, Section 2, except I would, as I said earlier, go through and replace all my double angles first. Okay, now that brings us to some problems where we can use a half angle identity. So here's a problem that we did in Section 3. Cosine of 15 degrees, we want the exact value. Well, we're going to go about getting it a different way. There, in that section, we used a sum or difference identity. Here we're going to use a half angle identity. Now, why will that work here? Because 15 is equal to 30 over 2. And the reason that that's helpful is because 30 is on the unit circle. Okay, so now if we go apply this identity, cosine of a over 2 is equal to plus or minus the square root of 1 plus cosine a over 2. So you say, well, which is it, plus or minus? Well, this one's 15 degrees, and so we know we're in the first quadrant, so we know cosine has to be positive. So what am I going to have here? Cosine of 30 over 2 is going to equal positive the square root of 1 plus cosine 30 all over 2. Okay, now let's do some simplifying. Whoa. So that's going to equal the square root of 1 plus cosine at 30 is root 3 over 2 over 2, which would equal, we'll get common denominators here, so I'll have a factor of 2 down here and a factor of 2 in the numerator. So we'll have the square root of 2 plus the square root of 3 over 2 over 2, which really is the same thing as 2 plus the square root of 3 over 2 times a half, which is equal to, and I'm running out of room here, so I'm going to get over into this other problem a little bit, the square root of 2 plus the square root of 3 over 4, which is equal to the square root of 2 plus the square root of 3 all over, and the square root of 4 is 2. So there you go. There's the exact value of cosine of 15 degrees. The square root of 2 plus the square root of 3 all over 2. So there's you a half angle with cosine. So this next problem is going to get us into finding an exact value using a half angle identity for tangent. So we know that 22.5 is equal to 45 over 2. Okay, so now we're going to apply this formula, 1 minus cosine A over sine A. Or we could apply sine A over 1 plus cosine A. Or we could apply square root of 1 minus cosine A over 1 plus cosine A. We could use any of those. It doesn't really matter. The bottom one looks just as simple to me as any of them, so that's the one I'm going to use. So, what's that going to give me here then? Oops, didn't realize I was going to do that. Well, then I would have 1 minus the cosine of 45 all over the sine of 45. Okay, now let's work on simplifying that then. So we'll have 1 minus the square root of 2 over 2 over the square root of 2 over 2, right? Cosine of 45 is root 2 over 2, and so is sine. Alright, let's get common denominators in the numerator. So we'll need a factor of 2 down here and up here. So I have 2 minus root 2 over 2 over root 2 over 2. And those 2's would cancel. So I have 2 minus root 2 over root 2. And now we'll rationalize the denominator by multiplying by root 2 and also in the numerator. So the numerator is now going to be 2 times the square root of 2 minus square root of 2 times square root of 2 is 2 all over 2. But then I could factor out a 2. If I do that, I'll have root 2 minus 1 left in the parentheses. And now the 2's would cancel. So at the end of the day, the cosine, or what was it here? Hang on a minute. What was I looking for? The tangent of 22.5 is equal to the square root of 2 minus 1. Interesting. Okay, and that brings us to this last problem here, example 10. And this is an excellent problem, and I would expect to see something like this on your final. The reason that it's good is because it makes you be analytical. We can't really give you a step-by-step set of instructions on how to do problems like this one because every problem's different. So we're just going to have to analyze what's given to us and from that try to find what we're looking for. Now, rather than do all three of these, sine of s over 2, cosine of s over 2, and tangent of s over 2, I think I'll just pick one because I think that'll illustrate how to do the others. So, let's go back up here and take a look. One's about the same as the other. So, let's find cosine of a over 2. Which to do that, I'm going to need 1 plus cosine a over 2. Okay, so cosine s over 2 is equal to 1 plus cosine s all over 2, and I failed to get the square root, didn't I? Yep. And it's going to be either plus or minus, we don't know yet. Okay, well, At first glance here, this doesn't appear too bad. It appears kind of innocent because we know what cosine s is. So we'll work on the plus or minus here in a few minutes. Let's just work on the square root part right now. So we'd have the square root of 1 plus, we know cosine s is 2/3 all over 2. If we get common denominators in the numerator, we would need factors of 3. So what's that going to give me? That's going to give me 3 plus 2 is 5/3 over 2, square root of that, which would be the same thing as 5/3 times a half, which would be the square root of 5/6, or the square root of 5 over the square root of 6. And if I rationalize the denominator, I'm going to have the square root of 30 over 6. So now we got to figure out what the sign is. Okay, and the secret to that is right here. It's not as straightforward as you think. We know that s is in the fourth quadrant because it's between 3 pi over 2 and 2 pi. But the question is, where's s over 2? Well, here's an easy way to figure that. Let's start with the inequality that we have right here. 3 pi over 2 is less than s, less than 2 pi. Now, I'm interested in s over 2. So if I divide that by 2, I would need to divide the other 2 by 2 as well. So divide by 2 here, and dividing 3 pi over 2 would give me another factor of 2 in the denominator. So if s is between 3 pi over 2 and 2 pi, then let's see. Do you see that s over 2 is going to be between 3 pi over 4 and pi? Which puts us in the second quadrant. And in the second quadrant, remember we're looking for cosine here. In the second quadrant, cosine is negative. So we'd end up here with negative, well, that's not very pretty. How about this? Negative the square root of 30 over 6. And you could figure sine and tangent in similar fashion.